next we have the panel for use cases of AM in the Department of Defense. I'm excited to be moderating this panel, and I will be bringing Cindy Waters and Megan Cooney up to the stage here, and we will get started. Okay, and it looks like we have Megan with us, and Cindy, you're here too. Welcome.
Yeah, great.
Well, I want to just do a brief introduction. I know both of you have really impressive bios, and I just want to tell the audience a little bit about who you are, and then I'll turn it over to you and let you talk a little bit more about what you do and why you're here. I'd like to start with Dr. Cindy Waters. She is the Senior Science Technology Manager Principal for Advanced Materials and Manufacturing, a Naval Surface Warfare Center. She transitioned from being a tenured faculty member into the dynamic Naval Research 2019. I'll let her tell you more about her experience and what she does, but I'd also like to introduce first Megan Cooney, Principal Manufacturing Engineer for Northrop Grumman in Baltimore, Maryland. She specializes in metal AM, and we'll let her also share a little bit more about herself. And I think that's a great way to kick off the panel. Can you tell us a little bit more about your background and how you got into AM, and then just a little bit more about what you do? And Dr. Waters, we'll let you go first.
Yeah, you can just say Cindy, it's fine. So you know, I talk about this as just a women in AM conference. So I raised 4 children, went back to school, got my doctorate, started in academia. Well, then started my tenure track position in academia. I was a material scientist by training. I was in a mechanical engineering department, but started in powder metallurgy. So really, it was interesting. Powder metallurgy then led me to efforts in binder jet printing. And I was working pretty closely with Dr. Amy Elliott, who was, I believe, one of these track leaders here at Oak Ridge. And so got really interested in AM. So had multiple graduate students. And then, you know, tenure came along, life changes, my husband retired, things moved. I thought, well, do I want to continue in a tenure track position, or do I want something different? Do I want a new challenge? And so the answer was, you know, exclamation point, a new challenge. So joined the Naval Surface Warfare Center at Carter Rock, actually joined in their AM branch as a senior researcher in their AM branch, but then a few months later transitioned into the position I am now. But it's really exciting. I get to work with all sorts of amazing women and men in AM efforts, but not just AM, but the welding branch, which is where we are leads, and I'll talk a little bit more later about cold spray. But in a lot of the materials, manufacturing, non-destructive evaluation efforts. So that's a little bit about me. So.
Perfect. I can jump in with my introductions next, just kind of doing a tech check to make sure you can hear me.
Yes.
Perfect. Okay. Well, thank you, Melanie, and thanks, Cindy, for starting us off. I'm really excited to be giving this talk today and having this discussion with Cindy. Like Melanie introduced me, my name is Megan Cooney. I'm a principal manufacturing engineer for Northrop Grumman, located in Baltimore, Maryland. For just a little bit of an organizational context, Northrop is one of the leaders in the aerospace and defense industry for government contracting. So we support the U.S. warfighter and are focused on several different complex systems, including aircraft, spacecraft, cybersecurity systems, and radars, which is where my work comes in Baltimore. Within the sector that I operate in, mission systems, we focus on radars and satellites with an intentional deliverable guidelines for electronic and thermal systems. For kind of my day-to-day role in my focus area is in metal additive manufacturing, specifically I focus on kind of production, utilization, what we're putting on machines, why we're putting it on the machines, which is what I'm so excited to be having this conversation about. A lot of what I focus on is design for additive manufacturing in collaboration with design engineers. And then in recent months, it's turned into a process improvement role as well, kind of seeing the holes in our system and how we can develop them further. I'm really interested in the post-processing side of metal AM, so a focus on advanced machining and tooling, post-processing, metrology, scanning, all the different ways to kind of enhance additive manufacturing and its usability in our industry. For my educational background, my degree is in mechanical. I have my bachelor's degree from the University of South Carolina. I started at Northrop right after university, jumped straight into manufacturing and kind of never looked back. As soon as I found additive, I knew it was the place I wanted to be. And I am in my final semester of my master's degree, also in mechanical engineering from Hopkins. So I'm earlier in my career, but I'm really, really excited to be discussing AM. It's something I'm super passionate about, and especially this use cases discussion, I think would be great.
Nice, nice. It's funny. It's a small world. So I spent about 5 years at University of South Carolina in the mechanical engineering department. So that was before I moved to North Carolina and so forth. So yeah, small world. It's good. It's good to know people.
Love it.
Well, that's great. Well, let's get into the heart of what we're here to talk about, which is the use cases. So let's each of you have a chance to go through some specific use cases of how AM is being used in the DoD. And Cindy, if you want to go ahead and get started.
All right, and I was going to share a few slides, not a lot, but let's see if this will work. Start sharing. Let's go to that. Do you see that? Let's see. How do I share? Oh, I have to say share. Window, entire screen, window, there. Tell me you see it. No, yes?
We don't see it yet, Cindy, but if it's the same slides that you sent me, I can share.
Yes, if you could share, that's great. It's the same thing I sent you, yes. Why is it not working? Let's see, we'll choose to share. It's not letting me do it. Chrome tab, entire screen. While you're doing that, I won't have dead air. I will say, while you can find that and bring that up, I mean, it was so much fun to listen to the previous speaker, Marilyn Gasca, because so much of what, there it is, so much of what she was talking about, I have been a part of. You know, the JAMWIG organization, which is the Joint Additive Manufacturing Working Group, the AMO, the Additive Manufacturing Maintenance Operations Group, I've been a part of that Lockheed hosts. The Air Force Olympics, I was a judge on one of those. So it's fun how there's so many overlaps in this, large world that we live in, but I feel like AM is a small community. So it's kind of fun. All right, so you can go, that's just the classic first one. So Carter Rock, this is the only slide really on background. Carter Rock is one of the Naval Surface Warfare Centers, and we're divided into 3 main departments. The Platform Integrity Department, which is where I am positioned, the Signatures Department, which actually, you all may be interested in, and then the Naval Architecture and Engineering Department. So those are the 3 big departments, and we have, hundreds of PhDs, a lot of really great research goes on. Next slide. So platform integrity more specifically, so that's where I am. And the divisions there, you can see materials and manufacturing, environmental and energy, structures and composites, and survivability and weapons effects. So yeah, we do depend on our OEMs and the large manufacturing companies to help us to come up with these new techniques and manufacturing processes. But we also fill in at Carter Rock with a lot of that materials work, background work, and the manufacturing work that we know might have to take us over the finish line. We know that there are these great AM techniques and there's great machines that have been built, but will that machine be appropriate to use out in the fleet? Well, there's some additional work and research that needs to go into that to figure that out. So, but also in that materials and manufacturing, where the time is where I spend most of my time, we have, as I said earlier, welding and non-destructive evaluation and non-metallics division. We have our polymers division. We have our corrosion division. So all of these problems that AM may need to address, for instance, how many times do I hear, well, what is the corrosion behavior of a 3D printed part? Okay, so I need that definitive study that says what's going to happen. And if we can't find it in the literature, then we need to be doing that ourselves. So a lot of interesting work. So next slide. So I won't say all these words, but additive manufacturing. I mean, we work closely with the Marine Corps. with Office of Naval Research. We are a NAVC organization, so we definitely lead a lot of the NAVC efforts. And we work closely with the other warfare centers. So I didn't know anything about warfare centers very little before I joined. There are multiple warfare centers across the United States, and each has a more specific mission. You saw the departments at Carter-Rock. Well, there's another warfare center at Indian Head, which is Southwest Virginia. There's another one in Indiana, Crane. There's another one in Port Hueneme in California and Corona. So each one has a different kind of mission. We are, as you saw, materials manufacturing processes in that architectural design. So next slide. So really, you know, what do we do in AM? We do, honestly, we're trying to do bits of it all, or at least on our AM team, which is made up of 20 plus great engineers. And I'll try to call out a few of them here. I think Marilyn did such a great job earlier, really putting the names out for some of the women too that work on the team. So I'm going to try to do the same. But we try to be those subject matter experts. And so we want to be the people that the fleet, you know, when a 4-star admiral or something comes to, you know, has a question about AM, we want him to come to Carter-Rock and say, all right, I've heard about this blank, you know, this technique. What do you know about it? And so I like to say that our job many times is two-handed. One, we convince people to utilize AM. You know, we may talk with the shipyards, we talk with the PEO Columbia class and say, okay, you're having a problem getting some of these parts cast. Maybe, it's a big maybe, we could help with some AM parts. You know, maybe we could ease the burden on the casting houses by doing this. So in one hand, we might have to convince folks that AM is ready for prime time, that, you know, the certification process, whether it's in situ or afterwards, lends enough confidence that we could use that. And I love the NASA talk earlier. You know, really honestly, if NASA can put it on a rocket that's blasting off, certainly we in the Navy should be able to utilize that in some of our applications. But so that's the one, convince. But the other side of it, sometimes we have to rein people in. We have to say, you know, because the higher ups at the Pentagon are going to see something on LinkedIn or see it somewhere and say, wow, that looks great. Can't we print all of our blank, fill in the blank? And so sometimes we have to say, well, you know, no, we really can't print all those things. But what you see here in this slide is, you know, we've got this wonderful make lab, and we take these lessons that we learn. So that's kind of our two-handed. We educate, but then sometimes we rein in. But we also then are sharing what we know about these AM systems out with the fleet. So if you go to the next slide, you know, there's an AM at sea effort. So these are, you know, publicly distributed. These are some old examples, and you may have seen these before if you've been to other NAVC presentations. But we're putting printers on active duty ships and submarines. Now, we're not putting metal printers out there yet. You know, think about those of you that are more into metal AM. In the back of your head, you're thinking, putting it on an active ship. Well, what does a ship do? Does it sit really still in a port? No. And so, you know, there's issues, right? And so we work with the at-sea folks and really try to decide on the best printers that they might use in their applications. But, you know, the goal really is to expand the capability to the point of need. And so, you know, these are mostly polymers, but still they can print a good bit more. And I think, you know, that's where we depend on industry to really help us come up with more materials. You know, if we can use some advanced or stronger materials in an FDM printer, well, that's pretty cool. All right, next slide. I'll go quickly through this. Same thing, shorten the supply chain. Go to the next slide. Challenges, right? So here's some of those challenges. What's the effect of motions on vibrations on a 3D print? Somebody was talking earlier about what happens when a print gets stalled for several hours and you've got to restart it. Well, yeah, that could happen. The other thing, you know, we have some commonality with NASA if you want to print out in space, you need to worry about the off-gassing of those polymers. Well, same thing. If we want to print on a submarine, well, we've got to worry about some of those. So there's some of those polymers that we worry about. Post-processing, right? We definitely need to be looking at that. And then does the additive manufacturing equipment respond to those challenging conditions? Next slide. Marine Corps, we love working with the Marine Corps. The Marine Corps have a high tolerance for risk. And we have created systems, a TacFab and an XFab, one's smaller, one's bigger systems that can actually go out into the expeditionary units. And really, the commandant of the Marine Corps said, I don't need it to be perfect. If I'm going to print a replacement part at the point of need, I need it to be good enough. Is it good enough to get us back to where we can be? So you can kind of see that reduce the stockpile of spare parts, leverage critical nodes in the supply chain, and maybe work on decreasing complexity of that supply chain. So next slide, which might be the last. There's two of them. This is an example of the TacFab Kit. Do you see those boxes on the back of the truck, those black boxes? So what we've done at Carderock is come up with the minimum amount of equipment that a group could use to really make a difference. So the TacFab Kit is packaged for transport, and they actually throw these things off of moving trains. They really test the rigor of these packaging that they have for these, and then it allows the warfighters to use these wherever they might be. Next slide. The bigger unit then is the XFab Shelter. So it's like a Connex box, one of those boxes, and those are interior, and so those are a little bit more AM capabilities. But this is part of what we're doing at Carderock. Now, I could go into more, and I don't want to I'll stop here in a second. We're also, you could go, I think that was the last slide. Go to the next one just to see. Yes, you can take off the slide deck now. So other applications, other things that we're talking when we talk use cases, we are definitely looking at cold spray. So I think there was some chatter in the previous talk about is cold spray an additive technique? Well, we believe it is. Cold spray is a wonderful technology too when you've got a fleet of ships that are getting old, and corrosion is happening, and stress corrosion cracking is happening. It's probably not even ships. I'm sure in the Air Force, I'm not sure, I know they have the same problems. Cold spray is going to be and is a good solution to repair some of those issues. We're looking at we're utilizing and researching friction stir welding. Don't know if you know about friction stir welding. There's a group out of that branched off out of Virginia Tech, MELD group, and friction stir additive actually. And I like to say there, it's like taking that stick of butter and you're rubbing it across the ear of corn, right? So you're slowly leaving that material by, and when it's additive, you're building up layer by layer. So we're interested in that. And one of the things too, we are going to be getting one of the Lockheed Martin laser wire feed systems that Dr. Jen Wolk at ONR, she supported a project called Quality Made. And the Quality Made project really looked at a whole suite of Insitu Monitoring devices and processes. And one of those is on one of the Lockheed Martin laser wire systems. So we're definitely interested in laser arc laser wire additive. We're interested in wire arc additive. We definitely utilize powder bed. We are looking at the MEM system, the Metal X Mark Xforged system. So honestly, if you name it, we're trying to utilize it. And our applications really are at the point of need, but we're also, and after this, I'll stop and let my partner in crime speak a little bit more. We are trying to work more with the naval architects. So if you saw at the beginning slide, Carderock has one whole department that's called naval architecture. And those are the folks that are trying to design the next generation, the next thing. And so I've always said it's, we're not fully utilizing AM until we start designing for additive, right? And you certainly know what I'm talking about. And so there's also the education piece to educate them as to the art of the possible. So with that, I will pass the baton.
Thank you, Cindy. I feel like that was the perfect note to end on how important it is to design for AM. And just a couple things picking up from your slide, the enduring themes and the challenges, I think those in themselves could be hours worth of discussion. So it's easy to say that, but there's so much information to, and there's a lot of collaborations and challenges between industry and NAVSEA, which I'm totally seeing evident just in the few comments you're making. Like I mentioned before, my background and focus area is in powder bed fusion, specifically for radars, satellites, electronic components. But I'll try to kind of think of use cases for AM from a more holistic approach for the Department of Defense in general. I think there are overlaps with other industries that the fashion, medical, automotive industry would see as well, but there are many use cases that are super specific to the Department of Defense. One that immediately comes to mind is complex geometry. So the way that AM allows you to fabricate really difficult, quirky features, fine features, internal channels, those are super critical to the Department of Defense and enabling our warfighter with cooling systems, thermal systems, electronic components that have features that you're not able to traditionally. I think another huge win relative to aerospace that AM can contribute to is lightweighting parts. So I've actually been working on a project recently that uses topology optimization. So our ability to kind of engage that practice and remove weight from parts makes them better suited for spacecraft and aerospace applications, which is a critical technology for the Department of Defense. I also think one of the kind of like buzzwords, golden themes of additive is part consolidation, which is huge for the Department of Defense, because if we're able to remove assembly, remove interfaces, eliminate hardware, it saves money, time, effort, labor across the board. So I'm sure many of us are familiar with the GE jet fuel nozzle, and that's prime example of consolidating parts, removing extra pieces, and that's really only able to do through AM. I think another huge benefit to AM in the DoD is the fact that it's a rapid technology. So many times the point of need, that's really where AM thrives, is that we can turn something around super quickly. It can be iterative, it can modify as needed based on what the designer needs, based on what the service members need, what the current environment that the ship is on. You know, all different kinds of factors can lead to a rapid turnaround prototype. So for those few reasons, there's so many more. I think AM is a huge asset to the Department of Defense. In terms of use cases that I specifically deal with, it's really kind of tooling, research and design, and then deliverable product where we are using complex geometries, internal features, removing weight from a part, and quickly turning so that we can rapidly, efficiently, quickly service the warfighter, provide the warfighter with product that they need to go out and protect, defend, and establish as the Department of Defense.
Megan, for some of those use cases that you talked about, particularly for electronics that you're focused in, can you talk about at all the materials that you work with? And then Cindy,
Yes.
you also talk with some of the most common materials that you see in your use cases.
Sure.
Absolutely. I think material consideration is really important in the Department of Defense. I know it's something that Cindy and I could talk for a long time about, but qualification and standardization of AM parts is really specific to the Department of Defense. And one huge part of that is qualifying our material. So my background, what we do at Northrop in my sector is almost all aluminum focused. So it's finding strong metal that's durable, that's readily accessible. We also do polymers work, so we can use Ultim for that, you know, various softer plastics. I focus in aluminum. There's also exploration for high strength aluminum. And then there's different powder bed fusion or metal AM exploration into titanium, into Inconel, into copper, various really like high strength materials for long-term durable applications, or kind of more flexible, cheaper material for one-time use.
Yeah, so you know, once again, a lot of overlap. You know, we as a Navy, we use a lot of stainless steel. So we certainly, you know, stainless steels are there. When we're looking with the wire arc, though, you know, we're working with some of the aluminums. Definitely titanium is in the list if we are going to some of those critical parts that may go on one of the platforms. You know, we're looking at titanium, and we know, you know, advantage of if we can print with titanium, it's quite expensive now, and the ability to cast titanium is next to almost gone in the United States, and really worldwide. We're losing that ability. So you want to part out of titanium, right? You know, you're either machining it and losing a lot of material, or you can print with it. So I think we're really interested in that. Just, you know, the printing side. Did you want to add? I saw you.
Yeah, I was going to say, and I think in contrast to some other industries where it's kind of a completely like abstract creative idea, for the Department of Defense, you're often comparing yourself to the raw materials. So that's exactly the case with titanium and with aluminum. When you're going the AM route, you have to prove viability compared to its traditional material characteristics.
Yeah, and that's multiple times I have that conversation. You know, when a part was cast years ago, if you look at the interior microstructure, or it's, you know, if we would micro CT it, it wasn't perfect. But now, if we're going to print it, we want it to be what? Perfect. You know, we don't want any of those pores, any of those things. And it's, you know, so I think that is a opportunity / challenge, is to manage expectations, right? To remind people that, you know, it might not have to be perfect. You know, it's interesting though. We know that there's other opportunities, and so we work closely with not just with America Makes, but NextFlex is a flexible electronics group out of I think California. It's another one of the big manufacturing centers, and they're doing flexible and printed electronics. So, you know, that's something else we're interested in, definitely. And yeah, there's so many applications. I'm looking at some of the comments too. You know, we certainly work with all the polymers. If you can imagine, any of the polymers, you know, some of the Ultems, the cheaper ones on the ship. I chuckle at a story. One of my son-in-laws was a naval nuclear officer on one of the Boomer class submarines, and we were talking a month or so ago, and I was talking about printers on a submarine. He's like, "Wow, we didn't have those when I was on my rotation." He's like, but, and I was telling him some of the examples, some of the things that people think are just simple, like maybe the door to a locker or something in the kitchen to replace something that's broken. And he said, and his eyes got big when I talked about a kitchen thing, and he said, the nozzle on the ice cream machine. He's like, when that goes down, he's like, it went down when I was out rotation. He's like, that's a killer, man. It's just so you know, we sometimes think some of these parts that we're printing are just it doesn't really matter. But if it's quality of life that's affected on you know, in some of these active duty, then it's important. So
yeah, you ladies are bringing up a lot of good points sort of as we go through this. And, you know, one of the things I wanted to get into a little bit are some of the challenges that might be unique. I've heard a few weaved in there, you know, the qualification, certification, you know, and just in general, the historic comfort of traditional processes. And you kind of talked to that, Cindy, about sometimes AM is held to a higher standard than other more traditional manufacturing processes would be. So if you could take some time and just talk about some of the challenges particular to these DoD use cases.
I'm happy to jump right in. Okay, perfect. So I know we mentioned kind of the difficulty with qualification and standardization, but one thing that I'm constantly focused on is the, did we lose Cindy?
Don't worry, we'll get her back up.
Okay, perfect. I'll keep going. So I think the kind of the historical comfort with AM is something that we need to challenge. I know Sarah with JPL in her presentation a couple sessions back was mentioning one of their challenges is heritage parts. Similar challenge for us, but more so a heritage mindset, let's say, where we have kind of historic parts that are used to traditional manufacturing, and we need to convince engineers that AM is the way to go. And the best way, the strongest way to do that is with data. So we need to be constantly collecting data on our process to prove to the design engineering community that AM is a viable alternative. I think when we think about the specific challenges beyond, or maybe the reasoning for the hesitancy to adapt, I think what I see most often in the aerospace and defense industry is the direct comparison to traditional machined materials. So we're constantly being asked about achievable surface finish or as printed tolerances. So we need to kind of refine in those parameters and work through those steps, and so that we're able to kind of be an alternative to the traditional machining steps. I think we're constantly evaluating post-processing that can improve those features. And we're evaluating our in-process parameters so we can improve the as printed surface finish and as printed tolerances that our designers need. I also, we mentioned it earlier, but really one of the biggest hurdles in the aerospace and defense industry is standardization and qualification. I think that is what makes the DoD very specific than some of the other industries. Is if we're willing to put something into a spacecraft, onto a ship, into an aircraft, we need to be absolutely certain that it's going to function as intended, and it's not going to cause anyone harm, anything harm, that its form, fit, and function is really going to maintain throughout its part life cycle. So I think the qualification rigor and the mission assurance standards that we need to meet the Department of Defense are what make AM challenging to implement, but I think it is an achievable challenge, especially in the direction that the industry is heading. I think it's just collecting that data to get one step closer.
Yeah, that's awesome. And as part of a machine OEM, it's challenging because, what can we do to make the process have, better trust and enable the certification efforts? And that kind of goes right into one of the questions that was asked by the audience here, which is, does Insitu monitoring during the build process play a role in the qualification of AM parts and materials?
Absolutely, and that's a great question, and it's something that industry is very focused on. So in just the last few months, we've been kind of diving into Insitu monitoring and taking data points on our process as it's printing so that we can see what kind of build behavior is affecting our end result parts. And having that data so that we can present it to our mission assurance team and work to qualify these parts is really critical. So there's all kinds of kind of software developments out there that are aiding in Insitu monitoring, are compatible with AM machines. And I think OEMs, like you were saying, are very engaged with Insitu monitoring abilities so that we're better able to qualify parts given data that we can collect during the process.
Okay, great. Thank you. Another question here. This is more on the feedstock. The question is, do you prefer to work with AM versions of powder or filament of traditional materials such as Ti-64, Ultem, or do you think we should focus on developing new materials for AM?
And do you want Cindy to take that? Because she can join over the phone as well.
Can you hear me on the phone here?
Yes, we can.
Yep, we can hear you, Cindy.
Great.
So I can.
think I'm actually backed up too, but.
Okay, go for it, Megan. Yep.
Okay. Yep. I'll go ahead and just jump into the material question.
Yeah.
That's really good in the topical debate. I think for the Department of Defense challenges we face, I think we are better suited on traditional materials that have kind of qualification in process for AM. But there's definitely a need for material exploration. So we experience with copper, and I think that's well worth developing. I think there are some industries that have much more material freedom per se than the DoD does have. So I think kind of finding that fine line between material exploration for like data collection development versus putting deliverable product into the fleet that's made from a reliable material.
All right, so I am sorry, my internet just died, but anyway, I'm back. So thank you for taking over. Yeah, so materials, we want dependable materials. We need materials that can be repeatable, that we know that we can have a supply of, that material. And I think that I'm looking at another comment too, talking about cost sensitivity in the DoD. Well, we are cost sensitive. I know that there's this probably misconception that we can just spend all the money in the world. Well, if you live in the United States, the reality is it's our money. It's your money. It's my money. And Congress does hold us accountable for cost. So, we definitely want the projects to be cost sensitive, but generally, time is money. So the AM project still will likely save you money if, you get things straight. Now, the challenge is those one-offs, that's which AM can be good for.
And I think the cost sensitivity brings up a really interesting point that we want to prove that AM is a viable alternative, and we aren't going to be able to do that with sky high costs. Nobody's gonna want to go our way as opposed to traditional machining. So I think, to Cindy's point, there's definitely a misconception that money has no ceiling in the DoD, but we're constantly working under budgetary constraints to stay within a defined cost.
Okay, awesome. Thank you. I think there's one question left in the chat, and then I'll open it back up for any closing thoughts. The last question is, how do you send print files to the ships? So maybe not just specific to the ships, but in general, can you talk a little bit about the digital side and sort of the front end of how data gets passed around?
So not going to lie, that's a tricky one. We do work with America Makes, so the JAMX that Marilyn mentioned earlier, it's a file exchange opportunity. And many times the files will be on the ship and there's no internet, there's no nothing. And that is a challenge with some of the AM machines, is the company wants to be able to update their systems via, Wi-Fi. Well, we can't have that machine, right? We have to have a machine that can be updated, while you're there. But when a ship does go into port, there are certain times where they can have an upload or a download of files. Definitely, there are certain criticality of parts. We actually hold something that's called a NAM-PI, which is a Naval Additive Manufacturing Part Identification Exercise. All these acronyms. But we work with the sailors and the Marines and help them understand what would be appropriate to print. And then obviously there are critical parts that those files we don't want anybody to get a hold of. But if you're printing a ice cream machine nozzle, then it's not as critical. So the digital thread though file is tricky. Could blockchain help us with that? Who knows? So,
okay, thank you. I think
I'd love to take that question. There's one kind of other topic that I wanted to touch on. I am kind of pick Cindy's brain about, and kind of the future state of AM in the Department of Defense. And I think sending print files to the ships is the perfect example of that. Kind of where I see AM thriving in the future is if we can really nail down the digital thread and the software connection, connectivity, collaboration across platforms. And then I'd also love to see the warfighter and individual servicemen completely trained on AM. So similar to how you go through basic training, you also have an AM course in there, because this is the direction that the technology is heading. So I think future state, we nail down digital thread, we get across the board training. We have an entire fleet, whether it's land, air, sea, we have it all equipped with the ability to incorporate AM.
Yeah, and that's really important. And we are, at Carter Rock works with that. We work with the shipyards. we do work with the sailors, and we work hand in hand with America Makes. They've got some training exercises. We're working with a whole variety of entities on that training, because you're right. I mean, we train machinists, we train, although there's not enough machinists there, and we want to train those AM folks too. And yeah, we are desperate. I almost was talking to somebody back in the fall and saying, how we had Teach for America, and we had, all these different programs, but we need to have, like, how about American Makers? Have a program that we're encouraging people, young people out of high school, to go into making AM or something. I don't know. But yeah, a lot of opportunities. I did want to take a second before we end. A couple of the other women on the Carderock team, I wanted to mention the AM team. Dr. Caroline Vale, she's a rock star researcher, and so she leads a lot of the research efforts. Susan Havanek, program manager for our AM efforts. Erica Skates just joined the AM team at Carderock. She's program managing some of our big efforts with PEO, Columbia-class submarines. Lauren Hanyok was on the AM team and just took over leadership for the Capitol Tech Bridge. So if folks aren't aware of Navy tech bridges, you might look into those. Those are a way to get involved for industry and small companies. So I just want to give a shout out to those two.
Thanks so much for doing that, Cindy. And
well deserved.
Yeah, thank you. And you guys touched a little bit about the need for training and education and just sort of the whole people outreach. Is there anything else that you want to mention from a STEM perspective? I know, Megan, I think you do some outreach. Do you want to talk a little bit about that before we close?
Yeah, I would love to. So when we talk about training, I actually work quite closely with the Naval Academy, and they have a phenomenal additive manufacturing program.
Yeah.
They have a makerspace, and it's actually one of their proudest accomplishments that every single midshipman at the Naval Academy comes into the makerspace at some point. So they have some kind of exposure to AM, every single midshipman that's in the Naval Academy. So there's huge effort, huge interest in the Department of Defense to garner this exciting education. I think STEM education in general is critical to AM DoD. We need kind of those creative minds. We need to be tapping into educational resources early on. This wasn't intended to be a smooth transition, but in terms of more educational research and resources, last year the Joint Manufacturing Defense Council released their AM strategy for the Department of Defense, and it was kind of one of the best characterizations I've seen of the goals and the intent and the objectives of the Department of Defense and how it collaborates with AM. It's a fairly short PDF, so I'll go ahead and put it in the chat if anybody is curious on researching it a little more later. But I think it's a really, really good strategy outline for the U.S. Department of Defense.
Yeah, good.
Well, thank you so much. Thank you so much for posting that resource.
Yeah, that's a great idea to post that.
Well, our panel has come to a close. Again, I want to thank Dr. Cindy Waters and Megan Cooney for joining us today on this great panel. I'd invite you to stick around for some networking if you have time to answer some additional questions. And that's all for the industry track. So thank you so much to everyone for participating in TIPE and your support. And we will look forward to us hopefully seeing you back next year.